Hi there. Today I'm going to be talking about multiplying exponents with the same base. So what we've been doing so far has been simplifying when we have exponents as fractions or when we have negative or zero exponents. But now we're going to take a look at what happens when we actually do some operations with our exponents. So our rule is that if we have the same base, so in this example, x and x, we add our powers. So we have x to the a and we have x to the b. Our result is going to be x and then to the a plus b. This happens anytime that we're multiplying and we have the same base. I'll show you a couple examples of this in just a minute here. So for our first example, I have 2 to the third power and 2 to the fourth power. These are multiplied together, and you see here, I have 3 2's from this 2 to the 3. And I have 4 2's from this 2 to the 4. Now there are 7 total 2's, so that would give us 2 to the 7, since they're all multiplied together. If you remember your definition for exponents and bases, we can go backwards from that and get 2 to the 7 from this. And you should notice 3 plus 4 gives us 7. We can use this basic rule for any one of our problems that we're going to see today. Our first example here, we have 4 to the negative 5 times by 4 to the 8. Well, since these have the same base, we can follow our same rule that we had before. So we simply have 4, and then we're going to add our 2 powers together. So our base is still 4, and I add negative 5 plus 8. Well, what is negative 5 plus 8? Well, using our laws of negative numbers and combining them together, we should know that that'll come out to be a positive 3. So our answer is simply 4 to the third power, and we can go through and solve that further, and that will give us 64. For this second example here, I've got 3 terms, but since they all have the same base, that means we can still simply add the powers. So I've got 3 to the 6th power, I have 3 to the 3rd power, and I have 3 to the 4th power. So my result is going to still have a base of 3, and then I'm going to add 6 plus 3 plus 4. If I do this, it should give me 13. So I have 3 to the power of 13. And I'm going to need to grab my calculator because I can't quite do that in my head. But if I work this out, I should get a very large number here. So I get this very large number. Most of the time, you can just simply leave your answer as 3 to the 13. That's a lot easier to look at, a lot easier to work with than 1,500,094,323. So, for the most part, we can keep our answers in exponential form. Down here with this problem, I've got variables now instead of numbers, but that doesn't change anything. It still stays the same. I have x times by x to the 9. And this looks a little bit different because we don't see a power here with the x. But if there's nothing written there, that actually means that there is an invisible 1. We don't always write it because we don't need to. But there is, in fact, a 1 right there. So if I have x to the 1 and x to the 9, I can add those powers together, and I should get x to the 10. Just like that. Very simple. Down here with my fourth example, I once again have 3 terms. I have b to the 12, I have b to the negative 7, and I have b to the 11. I can go ahead and combine all 3 of these terms to get my final answer. If I have 12 minus 7, that gives me 5, and 5 plus 11 gives me 16. So my result is b to the 16th power. Now for our next slide here, we're going to combine the two together. So we're going to have numbers and variables. And this might look a little wacky at the moment, but really we can just follow our basic rules that we've been doing along with using some basic multiplication. So, for instance, I have 7a to the 3, b to the 6, times by 4a to the negative 2, b to the 8. Let's just separate this out into what we know. So for starters, 7 times 4. We should know that that's 28. So the number in front of our final answer is going to be 28. We simply multiply the numbers that are in front together. Okay? So the next thing I have is I have a to the 3 and a to the negative 2nd. Well, I know when I multiply those together that I'm going to have a base of a. So let's write that up there. And then I simply want to add 3 plus negative 2, or 3 minus 2, which is going to give me 1. And lastly, I'm going to have b to the 6th and b to the 8th. So when I multiply those, I'm still going to have a base of b. And I'm going to add 6 plus 8. Well, that gives me 14. So that's going to be to the 14th power right there. With my next example here, notice we now have numbers that are raised to the powers. Well, this doesn't change how we do anything. We simply, once again, need to add our powers together. So I have 3 as a base for both of my numbers, so that's still going to be the base with my product. Add 2 plus 3, which gives me 5. I know my next base is x because that's what comes next in both of my terms here. So I have x and x to the 14. Well, if you remember right, if we just see a variable by itself and no power, that means that it's a power of 1. So I'm going to write my little 1 in here. We know we're going to have a base of x. So now we're going to add our powers and get x to the 15th. Lastly, I have y to the 4 and y to the 5. So my base is going to be y. I add my powers together, and I get y to the 9th. So my answer here is 3 to the 5th, x to the 15th, y to the 9th. Alright, if you think you can do these 4 problems, go ahead and pause the video, try working out these problems, and then watch me and see if you get the same thing when I solve them. But I'm going to go through and try and show you how to solve these problems now. So for starters, r to the 12th times by r to the 5th. Well, since our base is the same here, we're just going to keep the same base, so we're going to have r, and we're going to add 12 and 5. And that'll give us r to the 17th. For the second one, since our numbers don't have the same base, we can simply multiply them. So 4 times 3 gives us 12. I have a to the 6th and a to the 9th. Those share the same base, so I'm going to have an a after the 12. And I'm going to add my powers of a. So 6 plus 9 gives me 15. So I have 12a to the 15 as my result. With the third example here, I don't have any numbers, so I can just go straight into the x's. I have x to the 6th and x to the negative 3rd. We keep our base of x, and we add our powers. 6 plus negative 3 is the same thing as 6 minus 3, and 6 minus 3 is 3. So I have x to the 3rd power. With the y's, once again, keep the same base of y, and I add 2 plus 0. Well, 2 plus 0 is just 2, so I still have y squared. So this is my result, x to the 3, y squared. With the last one, I have both numbers and letters, and my numbers are raised to a common power as well. So I have 5 to the 4th times by 5. Well, I know that that 5 without an exponent counts as having an exponent of 1. So I have 5 to the 4th and 5 to the 1. So I have my base of 5, and then I add my exponents. 4 plus 1 is 5. My next base is going to be m. I have m to the 7th and m to the 4th. If I add 7 and 4, I get 11. And then if I'm working with my n's, I know that that's going to be my next base. So n to the 10th and n to the negative 6, if I add those together, that's the same thing as 10 minus 6, which gives me 4. So I have n to the 4th. I hope this has been helpful for you. We will continue having videos like this, and I hope that you continue watching them. Thank you.